Okay, gonna get into the this week is the probability chapter. Okay, spend about basically a week on it. First thing we're going to talk about is possible outcomes. Now, tomorrow I will not be here. I have to go with the track team out of town for the track meet tomorrow. You'll have Coach James will be your substitute. Coach James helps me with baseball, the young guy that everybody thinks is a player because he looks so young. But he's not. And he will be showing you a video of my lecture last year on probabilities, and you will take notes over it, and you will have homework over it. Okay, but I will be here in video form. And I think, not sure if it's, can't remember if it's the one, it's actually from the 7th grade lecture, but it's the same. I cover the same material and everything. The examples will be a little different than what you would usually be used to, but because this is a new concept that we cover this year, next year, and in the next year after that. And so we cover it for the next 3 years. So introductory basically this year, and we go from there. But to basically talk about what we need to talk about today is we need to talk about possible outcomes, because probabilities basically deal with what is something going to happen. Is it going to happen? You hear all the time the probability of rain today is 20%, or the probability of rain today is 0%. Those are probabilities on the likelihood something's going to occur. Well, for us to be able to do that, we need to know how many outcomes there are that could be possible. For example, if I flip a coin, okay, I flip a coin, how many possible outcomes are there for that coin to land on? Jonah? 2. And what are they, Joy? Heads and tails. Okay, pretty simplistic. Okay, 2 possible outcomes. I can either land on heads or I can land on tails. Okay, now somebody would say, well, it could land on its side. Well, yeah, I guess. If it lands in a crack or something and it happens to land on its side in a crack, but the probability of you flipping that coin and it landing on its side or on standing straight up is very, 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 very high, and it's not going to happen. Okay, so 2 possible outcomes, heads and tails. Okay, so if we talk about what if we flip the coin 3 times? Okay, what if I flip the coin 3 times? How many possible outcomes are there at that point? In other words, think of it in these terms. I flip the coin, land on a head. I flip the coin again, land on a tail. Flip the coin again, I land on a head. Okay, well, that's 1 possible outcome. Okay, so I want to know how many possible outcomes there are for each one. So, for example, if I flip the coin 3 times, the first time you have heads, and then the second time I can have heads, and the third time I could have heads, right? Okay, well, the second one would be I could have tails, tails, and tails. That's the second possible outcome. Then I could have heads, heads, and tails. Okay? Then I could have heads, tails, heads. Then I could have tails, heads, heads. Okay. Now, I could also have heads, tails, and tails. Then I could have, should have done this with a tree diagram, it would have been easier. Let's see here. Looks like tails, tails, heads. Then let's see here. Tails, heads, tails. Okay. And I believe that's all of them. Should be all of them, if I've listed them right. Okay. So obviously, we don't want to have to sit there and figure out all of these different combinations to see how many outcomes there are. Because that's going to be the key of figuring out probabilities, is knowing how many outcomes there are and which are favorable versus unfavorable. Like, for example, if I'm at a football game and I want to receive the first half kickoff, I want to be on offense first, so when that referee flips the coin, okay, and I call a heads, that's a favorable outcome. I want it to land on heads so I can be get the ball first. Okay? Unfavorable would be that it lands on tails. Okay? And we'll talk more about those tomorrow, but that's the basis. You got to know totals, you got to know favorable outcomes, total outcomes, unfavorable outcomes. Okay? So, there's got to be an easier way than listing them all out or doing a tree diagram. A tree diagram would look like this. It would be your first row, you would be heads or tails. And then your second row would be heads, tails, heads, tails. And then these we would each have a heads, tails, heads, tails, heads, tails, heads, tails off of them. Okay, that would be a tree diagram. Okay, and if you look at this one, there would be your total. Okay? The other way they do it sometimes is they do it what they call a grid. Okay? This would be a list. This would be a tree diagram. And then they have a grid. A grid is where you would do a box like this. You have one. Up here you have heads, 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 and here you have tails, tails, tails. Okay, well, in this first box, no, hang on here. Is that right? Let's see, let me make sure. No, you can't. Let's see. No, that wouldn't be right. The grid, you're going to only have, let's see here. They do one that's a little different in the book. Yeah, they do one in the book. Look at page 46. They do one in the book that's a little easier to do because it's got two different things. It's got a number dice and a coin. Okay, on top of page 286 where it says way number 2, you can use a grid. It's basically like if you've done the DNA type of stuff in science yet, where they put the boy's gene and the girl's gene, or the black hair gene versus the blonde hair gene, and they're trying to figure out which one you're going to come up with, the dominant versus the passive gene, and so it's sort of what they do with genos when they're talking about DNA. Probably the most popular one that you will see is the tree diagram. I know they cover it in the 7th grade book. I know they cover it in the 8th grade book. They don't really cover these other two. They cover the list way some. They really don't cover the grid way much at all. Okay, so a grid is harder to do the more things you add to it. For example, flipping a coin, the same coin 3 different times, it becomes a little bit harder to do. Most of the ones that you're going to see today are going to be 2 different things. Okay, a deck of cards versus a dice, or a coin versus a dice, or a coin and a spinner, or a coin and number cards. All those are different types of things that are going to be done. But basically what you're trying to figure out is what is the total possible outcomes that could come up from the 2 events. Okay? I believe, there's really only 2 events when they're talking about flipping coins, rolling dice. Now, they'll call it a number cube. Okay? Just understand that a number cube is dice. Okay? I don't know why they don't call it dice. Maybe they don't want to, die, whatever you want to call it. Okay, they call it a number cube, and their number cubes look like, sometimes, for our purposes, when they give you a number cube, you're going to assume that it has 6 numbers on it, 1, 2, 3, 4, 5, 6. Okay, the number cube, for example, at the top of the page there in section 1, looks like, it only has 1, 3, and 5, and that's what they say. It only has 1, 3, and 5. We're going to assume that it has 6 numbers. Okay, we're going to assume that it has 1, 2, 3, 4, 5, 6, like all dice do. Okay, so when you're figuring it, figure that it has, unless they say something different, that it has the numbers 1 through 6. For example, look over at page 487 at number 7. Okay, number 7 says, pick a card and toss a 1 through 6 number cube. Okay, so they specifically have told you that it's got 6 numbers. Okay, so make sure that you understand that just because they only show you 3, it would be impossible to show you a number cube that had all 6 sides being shown in a 2-dimensional figure. Okay, you can't show 3 dimensions in a 2-dimensional figure. Now, let's look at some of those examples. Okay, what we have is we have what we call the fundamental counting principle. Okay? Basically what the fundamental counting principle is you basically take the number of outcomes per event and multiply them together, and that gives you the total outcomes. For example, we have a number cube, like in number 1, a dice. You toss or roll the dice. You roll the dice one time and you spin the spinner. One time. Okay? So you roll a dice, 1 through 6. Okay? You toss a number cube, then spin the spinner. They want us to use the fundamental counting principle to understand how many total outcomes we have. Now, it says there to make a list or a tree diagram or a grid. Okay? I just want us to use the fundamental theorem, I was going to another one, the counting principle. Okay? Fundamental counting principle. That's what I want us to use here. I don't want you to use tree diagram. We won't spend a lot of time on tree diagrams ever because they're, in my opinion, they're just a waste of lead, okay, or ink, depending which one you're using, hopefully lead. Okay, so we're going to use the counting principle. The counting principle for the dice, how many outcomes are there for a dice? If I'm going to roll the dice, how many numbers could I land on? 6. There's 6 possible numbers I could land on. Now, obviously, I'm only going to land on one of them. Okay, but there are 6 possible numbers that I could land on. On that spinner, okay, on that spinner, how many possible choices are there? 3. A, B, or C, correct? Okay, so it's A, B, or C. So I have on the spinner 3 options, A, B, or C. So to find out how many total possible outcomes there are for this event, I would take and multiply 3 times 6. 3 times 6 is 18. And that's the total possible outcomes. Okay? All right. Now, number 2. I will do it with a tree diagram so we can show you that both ways to produce the same answer. All right. So, it has a nickel. You're going to flip a nickel and pick a card. Now, what are the cards? 1, 2, and 3, correct? Okay. So, for a nickel, I have 2 options, heads and tails. Okay. For picking a card, I have 1, 2, 3, and I have 1, 2, 3. Well, if I look here at the end, that's the total possible outcomes. And how many total possible outcomes are there? 6. Okay? 6 different possible outcomes. Okay, how you would also come up with this if you use the counting principle. For the nickel, there is 2 outcomes. For the cards, there is 3 outcomes. So I take 3 times 2, that is 6. Okay? So the 2 ways are going to come up with the same answer. The tree diagram obviously is more work than the other. Okay? All right. Yes, Noah.
Why was it 3 under cards?
Huh?
I put cards number 3. Why was it number 3?
That's just what they chose. That's what they chose to use for their example. Because look at the picture. Yeah, if you look at the picture, it's 1, 2, and 3. All right, now, let's look to the next part. Number 3 says there's 6 shirts, 3 pair of shorts, 4 hats. Okay? They want to know the total possible outcomes, okay, for those situations. Okay, it said, let's see, yeah, they're saying here the number of choices. Okay, it says, now here's the key. You can only get 1 item from each category. Okay, that's the key in all of these. Okay, is that you're picking, like for the number cards, you can't pick 2 different number cards. You only pick once. Okay, you can only flip it once. Okay, you're not going to choose 2 shirts or 2 different pair of shorts or 3 hats. You're only going to choose one from each category. So if I have 6 shirts and I have 3 pair of shorts, right? And then 4 hats. Okay? Now, the total possible choices are simply this. 6 times 3 times 4. 6 times 3 times 4. 6 times 3 times 4 is 6 times 3 is 18. 18 times 4 is be 72. So there's 72 choices. So you can imagine if you had to use the tree diagram to work that out, that would be sort of difficult. Okay? All right, so that's how we figure out how many choices there. Now, ten ice cream flavors. 5 toppings. 4 syrups. 3 portion sizes. Need to follow along better, sir. All right, so how many total choices are there here? You're only going to pick one from each part or each category. 4? So to figure it out, you take 10 times 5 times 4 times 3. So you have 10 times 5, which is 50, times 4 times 3. 50 times 4 is 200, times 3. So 600 choices. Okay? So, in this section where it says to do a tree diagram or a list, you don't have to do that. You just use the fundamental counting principle for everything. Okay? You're going to do 19.1. You're going to do 1 through 15. Okay? You're doing it by yourself. Okay? You're doing it in pencil. And you're going to get to work. So no more talking, get to work.